Hi everybody. In part 2 of this video here, we're going to learn about a method or a process called dimensional analysis. Now, dimensional analysis, it's a method that allows us to convert between units, and that's the purpose of this, to convert from, say, micrometers to meters or from meters to millimeters. Okay. We're going to use the following steps when converting between metric prefix units. And remember, a prefix is that letter that goes out in front of a base unit. So maybe micro as in micrometer, or milli as in milliliter. Here are the two steps that we go through when we do this. We're going to convert from the given prefix unit to a base unit. And then if we need a second step, we're going to convert from the base unit to the desired prefix unit. All right. Note that there are more extensive descriptions of dimensional analysis. They're down at the bottom of the page. Let me scroll down and show you that right now. So we've got 5 steps down there. You can repeat those 5 steps to do any metric conversion. And then also down at the bottom here, I've got these 2 Kent chemistry videos. These Kent chemistry videos down at the bottom, these Kent chemistry videos are really high quality. They're already loaded up onto Canvas. Okay, so we're going to dive into doing 4 practice problems together. A lot of times when you do these, a good strategy is to lay out a plan for where you start and where you're ending. This is what the plan looks like. In this first example up here, it says how many meters are in 10 centimeters. See how you're given as 10 centimeters. So I'm going to start by writing centimeters. And then I draw an arrow to indicate one step to get from centimeters to meters. Okay, whenever you do this, metric conversion, dimensional analysis, you start by writing down the given number in unit. So that's 10.0 centimeters. Then we draw a big fraction with a horizontal fraction bar. And we always think top to bottom. The reason that we do this, moving around just the unit, is so that we can cancel like units. We're going to cancel centimeters, and we're going to convert to meters right here. See how there's one arrow, and we've got one fraction that has those 2 conversion factors on it, those 2 units of measurement. What I'd like you to do is to always put the number 1 along with the base unit. The base unit does not have a prefix. Then we go to our table of metric conversion factors, and we find centi. It says 10 to the minus 2, but we have to flip the sign with this method, so it's going to be 10 squared. All this means is that there are 10 squared, or 100 centimeters, in 1 meter. Just like in 1 week, there are 7 days. This is a true statement that these 2 things are equal to one another. Now we take out our calculator, and we would type in 10 divided by 10 squared, or 10 divided by 100. And the calculator would give us this number 0.1. But we need to do a little thinking here because we need to round this to the correct number of significant figures. Now remember, this conversion factor and any conversion factor has an infinite number of significant figures. So we want our final answer to have 3 significant figures. So what I need to do is I need to add on 2 zeros. Both of these zeros are ending zeros in a number with a decimal, so they're significant. So in this manner, we now have 3 significant figures, and we include units with our final answer. All right, we'll show this method a couple of times. Let me change the ink color. Here's another example. See how we're starting with 25.2 grams. And we're asked to convert that to milligrams. Okay, because we've got one arrow, we're going to have one fraction just like up above. We always start by writing down the given number in unit, so that's 25.2 grams. Draw my big fraction with a horizontal fraction bar. Whatever the unit is that I've got right here, I move that down to the bottom because when you have the same unit on the top being divided by the same unit on the bottom, they cancel out. Grams goes on the bottom, milligrams goes on top. Put the number 1 always along with the base unit. Go to the table of metric conversions and find milli. It says 10 to the minus 3, but we need to flip that sign on the exponent. So what this means is there are 10 to the 3rd milligrams in 1 gram. Said another way, there is 1,000 milligrams in 1 gram. Because this and this are both on the top, we multiply them together. And so the final calculator answer would be 25,200 milligrams. Check for significant figures. 3 sig figs, 3 sig figs, we're good to go. These are not significant zeros because they're ending zeros in a number that does not have a decimal. Okay, here's another example. You can see this is going to be a two-step example though. We start by laying out our plan. We're given decimeters and we're asked to go to centimeters, but we can't directly go from one prefix unit to another prefix unit. We always have to convert to a base if we're starting with a prefix and asked to convert to a prefix. Okay, so here we're going to go to centimeters. Now I notice that the unit deci is not up here. Deci would actually be right above the C for centimeters, so over here I'm going to put D, and a decimeter would be, it's an equal sign, 10 to the minus 1 base unit. Okay, so we're going to need that conversion factor that I wrote in right there. Okay, so we always start by writing down the given number in unit, 5.5 decimeters. We're going to set up a fraction. We move decimeters to the bottom, and we put meters on top. Next, we think about the numbers. See how I didn't even think about the numbers first? I thought about the units first so that I could get them laid out right. So in 1 meter, there is 10 to the positive 1 decimeters. Remember, we have to flip that sign from the table up here. I'm going to set up another fraction side by side of this. Since I've got a second arrow, I need a second fraction. And look, we're at meters, but we want to cancel meters and go to centimeters. 1 always goes with the prefix, the base unit, and then I look in the table of conversion factors, flip the sign, 10 squared. Okay, that's an equal sign right there. So I would multiply 5.5 times 10 squared divided by 10 to the first. If I type that into the calculator, I get 5.5 times 10 squared divided by 10 to the first. I get the number 55. Now that's nice because this number back here has 2 significant figures, and this number also has 2 significant figures. The units that I've converted to are centimeters. Okay, final example here. In this one, another two-step conversion. We're starting with 2.5 gigabytes and we're asked to convert to megabytes. So giga and mega are really big units of measurement. Gigabytes and megabytes, 10 to the 9th and 10 to the 6th bytes. So we're going to start out with gigabytes, and we always have to convert to the base unit, which is bytes, first, before we convert to the final prefix unit, which is capital M, megabytes. It's a megabyte right there. Okay? So we're talking about stuff that might be interested to computer science students. Because we've got 2 arrows, we're going to need 2 fractions. I start by writing down the given number, 2.50 in units, gigabytes, which is capital G, lowercase b, fraction, horizontal fraction bar. I always think top to bottom. And if I'm doing a conversion from a prefix unit to a prefix unit, I always have to go through the base unit, which is bytes right here. 1 goes along with the base unit, bytes. Then I find giga, and remember I still have to flip the sign. This is going to be 10 to the minus 9. But I don't want to stop at bytes. I want to convert bytes to megabytes. Think top to bottom always in the fractions. Put bytes on bottom so we can cancel it out. Megabytes on top. 1 goes along with the base unit. Check the table. Mega says 10 to the 6, but I need to flip the sign. So mega says 10 to the positive 6, but I flip the sign to 10 to the negative 6. Multiply across the top and divide by everything on the bottom. That means 2.5 times 10 to the minus 6 divided by 10 to the minus 9. It's a minus sign right there. So if I take out my calculator and I type that in, I get this number, and it's 2,500. And that would be megabytes. But I've got a problem here. Notice that I start with 3 significant figures, but I've only got 2 right here, 2,500. And I definitely can't stick a decimal right in there, because then that would be 250, right? And we don't want to drastically change the size of the number when we round. So what we need to do in this case is we need to convert this to scientific notation. Okay? If there were a decimal right here, we would move it 1, 2, 3 places to the left, and that would be 2.5 times 10 to the third megabytes. This has 2 sig figs, and we want 3, so all we need to do now is to stick a 0 on the end. And I know that's been a question that's come up a number of times in the activities recently. Remember, when you have a number expressed in scientific notation, you only look at the coefficient out front to figure out how many significant figures are there. So since this is an ending 0 in a number with a decimal, we have 3 significant figures here. And this still represents the number 2,500. Okay, so that's the method called dimensional analysis. We'll have a number of practice problems that are related to dimensional analysis coming out.